Okay, I think we are live. Welcome, Aaron, and thank you for joining our event. How are you today?
Good, thanks. How's it going?
I think we are live on YouTube and on LinkedIn. So, welcome everyone. My name is
Pretty
Bartosz,
cool.
and took I invited Aaron, who is my guest today, to discuss the future of OAuth framework, because I believe he is the best person I could ever get on board to the event that can talk about these things. So, Aaron, um, let me start with the short intro presentation, and I will give you a chance to speak just quickly. Hello, Kenny. Oh, Kenny is writing in the chat. Welcome, Kenny. Yeah, guys, if you can write something on the chat like hello, where you are from, it would be nice for us to know that we are not alone here. So, uh, sharing share my screen. Mhm. I believe we are sharing the screen right now. So, Aaron Parecki and Bartosz Pietrucha. I will introduce myself later on. Aaron, I know that you are very busy with security over the web. Can you tell us a little bit more how you're involved? I know you work for Okta, for Internet Engineering Task Force, but can you give us a short introduction of what is your role in these initiatives, these projects, and yeah, go on, please.
Yeah, for sure. So I'm Aaron Parecki, and I work at Okta on the developer relations team. And my main job there is doing trainings and education on OAuth and web security. And also through Okta, I participate in the IETF working group, which is where the OAuth work is actually and the spec is actually developed. So I'm involved in those conversations and work with a lot of amazing people there as well. At least one of who I also see in the chat here. So shout out to Vittorio. So yeah, that's my main role. I just really like helping people understand OAuth and help people learn about how to make their APIs and apps more secure.
Perfect. So yes, so as a person involved in internet engineering task force, you probably also work with different partners and companies because the standard thing has to be discussed in the public, right?
Yeah, that's one of the interesting things about the IETF is that it is everything is done in the open and in public, and there's a lot of different companies and people involved in that work, and it's very much a collaborative effort that's done pretty openly. So it's all everything's public in the mailing list. The events are open to anybody to join, and it's a lot of interesting people and a lot of different perspectives being brought to the work there.
Perfect. So thank you for that intro. For some people who not yet know me, we are streaming on our Dev Academy channel. My name is Bartosz Pietrucha, and I'm here on behalf of Web Security Academy, which is an online bootcamp that helps also developers to understand the nitty-gritty of security over the web. So we are kind of on the similar mission. You can find out more on the wsa.dev, and I believe this is for that moment enough. Before we start talking about the future of OAuth, which I believe is exciting that we have that person who works on that standardization online, let's have a short background check or some foundation that we understand and remind ourselves what is OAuth and why we need it for modern web applications. So if you think about the problem of integrating different applications, for example, the text messenger app is trying to import contacts from your Gmail. So, and this actually, and both of those applications have account for the same person. So as I am the user of this text messaging application, I might want to, allow this app to get my contacts from my Gmail. So what have we done in the past was, can we have can we share the login and password to Gmail? So I believe that the first thing that comes to your mind is this. By no means I would share my credentials to some third-party application. So the OAuth is trying to fill this need for integration of authorization with the standardized framework. So this looks like the first step is to send an authorization request to the application, and the user may allow or deny this kind of authorization. Once it is allowed, there is an access token given back to the initial client application that can use this token to call particular NPIs with a limited scope and limited lifetime, so that everything is some kind of sandboxed. And then the contact list is given back only if this request was authorized with this access token. And there are a couple of roles. We can have the client, which this is the application that is making this request on behalf of the resource owner. We have the resource owner who is capable of granting access to protected resource. And we have two entities, authorization server, who is actually doing the work with those tokens. And we have a resource server, which is actually hosting these protected resources. So these are all parts of the specification of OAuth framework. Those two servers may or may not be a same instance. They may be integrated into same application, or they may be separate. And single authorization server actually may issue access token, may issue access token accepted by multiple resource servers. And it is also important to have a differentiation between different kinds of clients. So as developers, we may have an application which is going to be considered a confidential client because it is able to store secrets securely, because in order to get these things authorized between client and the authorization server, we first need those client credentials in form of client ID and client secret. So if you have a backend like Java, PHP, and Node, when you can have the secret hidden, it's confidential client. And public client may be a Angular application, React application, like a single page application, when we cannot guarantee the secret being stored securely. And the last piece is that the client needs to be registered inside of this security token service. And before we jump into the discussion with Aaron, the last piece of information I would like to point here is that OAuth is an authorization framework, but it can be also used for authentication when we apply an additional layer on top of this framework, which is called OpenID Connect. Then this whole thing may be used for a delegated authentication. For example, when you see social logins with Google, GitHub, Facebook, this is basically that case. So I hope that this was a kind of very brief and quick introduction to OAuth. And now, Aaron, I would like to engage in a conversation with you, because you're like the person who is very deeply involved in these pieces of building blocks. If we just start with a simple question, like if I ask you how important is to know different security constraints of OAuth and OpenID, because at the end of the day, this approach is supposed to provide us with the secure approach for integrating different systems which are not integrated, right?
Yeah, it's a tough question. So I would say there's let me start up by saying most of the time, if you're going to be interacting with an OAuth or OpenID Connect server, the easiest and probably best, most secure way to do that is to use the library, a client library that was shipped by that project or that server. So using the client library shipped, provided, or any generic OAuth client library with these servers is a good idea, because a lot of this stuff is just sort of handled for you already, and you don't really need to worry about the details of what's happening. If you do need to write your own code to interact with an OAuth and OpenID Connect server, the good news is it doesn't take that much code, But there are then a few things to keep in mind about the security of the flows and what you should do and what not to do. And that's where it starts to get a little bit complicated or confusing, because over the 10 plus years that OAuth has existed and evolved, things have changed. The sort of recommendations have changed over time based on what new kinds of environments exist and new things discovered about the space. And that's where it starts to get kind of confusing when you're reading documentation that may have been written 6 years ago, and then it turns out that's actually not the current recommendations because things have changed since then. So that's where I'm coming in and saying, like, okay, I'm going to try to set the stage for you here and explain, like, what is today considered the best, most secure way to do things.
Yeah, but you mentioned also very important topic, different flows, because I believe the whole thing here has different levels, of complexity, which actually makes this problem multi-dimensional, right? So first of all, you need to think, okay, what is the right flow, right, in my setup? Because not to mention that this actually changes in the recent years, because as far as you guys under internal engineering task force consider some flows already legacy ones.
Yeah, and the good news is that this guidance is getting simpler now. So it used to be the case that there would be significant different flows that are recommended for different sort of environments. So mobile apps, single page apps, or a server-side app would have very different branches of like how you were expected to do things. But the good news is this is all consolidating now, and there's pretty much only one flow that you need to worry about at this point, which is the authorization code flow with PXE. And that is useful regardless of whether you have a client secret. It's useful whether you're writing a single page app or a server-side app or some sort of combination of the two. And that is, I would say, the default of just like assume that unless there's some extreme circumstance around your environment.
So you're saying that it's getting simpler and we can default to authorization code flow with PXE, right? So
Yeah,
PXE stands
exactly.
for proof. Can you help me
Yeah,
decipher
proof.
this?
PXE is spelled PKCE, and it stands for Proof Key for Code Exchange. It is one of those acronyms that I'm pretty sure was created so that it could be pronounced Pixie. But anyway, the point of it is that it's a mechanism for adding an additional layer of security into the authorization code flow, which provides a couple of really interesting attributes of security properties of the flow, and it is a better way to do the authorization code flow. And there's a lot of history there because it was created, it's actually not new, it was created quite a long time ago. I think it was like, I want to say 2013 or 2014. But when it was created, it was only really recommended that it was applied to mobile apps and native apps. And that was really the only place where it was talked about. And that was like, okay, if you're writing a native app, do PXE. If you're writing a desktop app, don't. Or if you're writing a web server app, don't do it. But that's the difference now, is that over the years, as new things have been discovered about the flows, and as browsers have caught up in terms of their abilities to be more of a platform for building applications compared to what they were 10 years ago, it turns out that PXE actually works not only in native apps, but also in single page apps. And there's a really, I would say, niche attack, but still possible to pull off in server-side apps that PXE prevents, which makes it also useful there. So the good news is, don't really worry, don't really think about it, just PXE everywhere.
That's great. That's great. So now, I mean, the second question that I would like to use as initiation for another angle of looking at this complex problem is: do we as developers need to know cryptography? Because we know that we call the APIs, stuff like that, but the thing is that under the hood there is a lot of cryptography happening, right? So do we need to know about that stuff, or we just forget about it and just call APIs and be happy?
Yeah, so there is a lot of cryptography involved in everything we do online, and most of it is sort of hidden under layers that we don't have to worry about. And the big one that I would say almost all of web security relies on, and including OAuth, is HTTPS, transport layer security, where we can go and make a connection to a server, and that connection, that pipe can be protected. It's encrypted, and that gives us a lot of really useful abilities to be able to send data in a way where we know that nobody can see it along the way. The good news is that is sort of the foundational layer of cryptography to everything, and for the most part, you do not need to know anything about how it actually works in order to use it, because you just tell
Hmm.
your HTTP library to go make an HTTPS connection, and everything just happens magically. So you really don't need to think about it in that case at all. And even if you're setting up a server, you really all you have to do is go and figure out how to get a certificate, which thankfully Let's Encrypt has made it super easy, and maybe think about which are the recommended cipher suites to use for the current, this year. And there's recommendations on like Mozilla's website and all that for that too. So you really don't need to know too much about it. The other place that cryptography happens in OAuth and OpenID Connect is in Pixie, because it uses a SHA-256 hash as part of that mechanism. And OpenID Connect's ID tokens are signed JSON web tokens signed with a private key, and you can verify it with
JSON
a
Web
public
Token,
key.
a hot topic amongst developers.
Quite. So those are the other places that cryptography is involved in the flows, and I would say in the case of Pixie, all you really need to know is how to use a SHA-256 library. Don't need to know anything else about how that works. And even then, you may not even need to know that, because if you're using an OAuth client, it should be doing Pixie automatically itself, and you don't have to know, even like touch it. The other place would be the ID tokens in OpenID Connect, and that gets a little more complicated because you need to be conscious of how the OpenID Connect server is configured and where you're getting ID tokens from in order to know how to validate them. But again, you don't really need to know the actual underlying crypto parts. You just need to know that it is a JSON Web Token, that it is signed, and that you can apply a JSON Web Token library to it to validate it.
Yeah, I just need to turn on some notifications. Great. Referring to the cryptography, the thing is that when I was doing my work to actually go down the rabbit hole of JSON Web Tokens, I remember that there were situations back in the day when yeah, of course, we are using something and so on. But do you remember this phenomenon when there were new JSON Web Token libraries popping out, and um, according to the specs, you have to have the non-algorithm implemented, and there were a bunch of pretty interesting implementations out there that, yeah, I mean, since we need to have a none, just allowing client to say this is used algorithm none. And what do you think about that back then when we had this strange um, situations?
Yeah, that is one of the unfortunate things about the JSON Web Token spec and about all of the JSON Web Token libraries that were built around that time, is that was just a giant mess. It's a bad idea. The non-algorithm is a bad idea to begin with. It is completely pointless, and should never have been introduced into the spec in the first place, in my opinion. And then the fact that the way that you would use the libraries would allow someone to go and create that JSON Web Token with that is not signed and have it be accepted is pretty bad. And the workaround is, of course, well, I guess, okay, let me back up. The actual underlying problem there is that there was a mismatch between what developers were thinking of as a signed, a complete package, a trusted thing, and external untrusted data. So as you're writing a web app, you need to be very conscious of when are you handling data that is sent to you from outside your little bubble, that you need to do some sort of validation of it before you trust it. And we're very used to this with like forms on the web, right? You write a web form, and you put like a drop down so people can choose what state they're in, and there's all the different states listed out in the drop down. And you don't just blindly store whatever value comes through that form, because it's trivial for someone to put any value into that, even though it's in a dropdown. And this is a pretty basic concept in web programming. And that same thing applies in the case of JSON Web Tokens as well. The problem with JSON Web Tokens is that until you've validated the signature, everything you're looking at is untrusted data, including the header, which contains the algorithm, which says which algorithm to use to validate it. So if you're using untrusted data to determine how to validate your tokens, that's a big problem. You need to use trusted data to know how to validate the signatures so that you can then be sure that the token is valid after you've done the validation through the trusted mechanism. So that's the underlying problem. It's not necessarily a problem with the spec, but the spec was written in such a way that it was sort of the natural evolution of the code around it led to these insecure practices.
Mm-hmm. Great. So now we are coming to the main point in this discussion, because we had some very nice, I believe, intro to the problem space, different angles, and so on. And now, what I wanted to ask you, Aaron, is what is the future of OAuth? Because I know that some changes are coming soon in so far 2.1 version of OAuth. And yeah, I mean, what we can expect as a developers, because we know what we use so far of 2.0, but what other new cool stuff we can expect or improvements?
Yeah, there's a couple of things going on. So OAuth 2.1 is an active effort right now in the group, with new versions coming out every couple of months. We have active meetings, ongoing meetings about the work. The idea with OAuth 2.1 is that it isn't actually going to be anything really new to people that are already following the work. So if you are following along with the work being done in the group in terms of the security best current practice, which describes a lot of sort of modern, updated security practices, such as always using Pixie and things like that. The idea with OAuth 2.1 is that it's really just a way to snapshot that and give it a name. So there's a sort of baseline understanding of what the industry considers to be best practices in OAuth right now. We want to give that a name, give that a point in time that can be referred to, so that we don't have to keep referring to OAuth core plus this other RFC plus this other one minus this thing minus that thing plus this other thing. So we're trying to sort of wrap it all up. And one of the opportunities this gives us, since we're essentially doing a complete rewrite of the spec and consolidating a bunch of stuff, is to just clean up a lot of language that is in the first draft or the original draft of OAuth. OAuth core was written a long time ago, and if you go read through it, I was kind of surprised as I've been working on the OAuth 2.1 effort, going back and reading some of the original paragraphs in there. There are quite a lot of things in there that are just written in a way that sounds just not current, not up to date anymore. There's a lot of things referring to old security practices or ways browsers used to work that just don't really apply anymore. And we have a chance to sort of clean all that up and take all that old language out of it. So it's really just meant to sort of modernize things. And it is an ongoing effort, so it's still in progress. It's not done yet, but we are making progress. In fact, I have a meeting literally right after this event with the other editors to continue that work.
We have a first question from Kenny. Where is this rewritten spec located so we can read it through? I guess it's under Internet Engineering Task Force library.
It
right?
is. Yeah. I'll drop a easier link into the chat for that. You can show that on the screen. OAuth.net/2.1 is the sort of unofficial link to it. OAuth.net is the site that I maintain, where I just try to make it.
Can you write it in the chat so that I can share it?
I dropped it into the chat. It should show up in here in a second.
Cool.
But that has the link out to the actual document. So that's a landing page that kind of describes the high level summary of it. And then the actual document is on the IETF website. And I always have a hard time finding things on there. So I prefer to have little shortcuts to it.
Mm-hmm.
Oh, I think YouTube is blocking it because it's a link.
Um, okay, because it's
Let me
OAuth.
send it over here, and you can
I can
copy
see
that.
on a private chat. Give me a
Yeah.
second. Okay. Maybe this would be easier if we do this. Mm-hmm.
YouTube probably doesn't like a
Now,
random. There we go.
yeah.
Okay.
So, I mean, any particular things that would change from our point of view? Because first of all, I hope that it will be backward compatible. Is that correct?
Um, more or less, yes. So again, um, there's not a lot of functional changes in OAuth 2.1 in terms of you shouldn't be surprised when you read it. What you will see though that you may consider to be not backwards compatible is Pixie is required. It is expected that
Okay.
you're always doing Pixie, and if you are following OAuth 2's best current practice right now, which is another document that group is working on, it already says that. So it's not necessarily new in OAuth 2.1, but Pixie is obviously not required in core OAuth 2.0 RFC 6749 because it didn't exist when that was written. So you may find that some OAuth client libraries, if they haven't been updated yet, won't support Pixie, so they're technically not OAuth 2.1 compliant. But a lot of the libraries already have been supporting it for a long time because, again, Pixie is not exactly new. It was written several years ago. There's a couple of other um, new requirements or deprecated things that, again, you could argue whether or not that means it's backwards compatible. But like the implicit grant is just taken out of the spec. So it is not a good
Implicit
idea to
flow is
use
going to be vanished, right? Totally.
completely gone. It's just gone. It does not exist anymore. And that is obviously it was in OAuth 2.0 and it is now no longer in OAuth 2.1. The main reason for that is because it was actually mostly in OAuth 2.0 as a hack in the first place because browsers couldn't do the regular auth code flow because of limits in browsers. We aren't limited by browsers from 2010 anymore, so we can do the authorization code flow with Pixie. So all this is to say that OAuth 2.1 is meant to, it's not meant to make you have to rewrite everything that you're doing because ideally you're already doing all the things described in OAuth 2.1 because you're doing OAuth securely. So if you
Mm-hmm.
are currently doing the most secure way of using OAuth 2.0, that is OAuth 2.1. There are a lot of things coming in the future in the OAuth group that are not becoming part of 2.1. There's a lot of new features, new abilities, new ways of doing things that are explicitly not getting adopted into 2.1 because they would be too different, or they would be more of a breaking change for people.
Can we talk about that actually? So,
Mm-hmm.
is it like that? In a summary, from our point of view as a developers, there are not many changes that we can expect in 2.1, but I assume we might hear some major release sometime in the future. Because I was wondering actually why 2.1. Maybe sometime we'll have version 3. I wonder if that is something that we already know or not.
Yeah, well, so OAuth 1, the difference between 1 and 2 was a breaking change. There is nothing about OAuth 1 that is useful when you're building an OAuth 2 system. So that was the reason for doing that major version number. In fact, there's even a lot of terminology that's completely different in OAuth 1 that we don't use in OAuth 2. So you can't even necessarily call things the same thing. So that was a breaking change. That makes sense. OAuth 2.1 is not a breaking change in that sense, in that most of the OAuth 2 code that exists is already fine and useful with OAuth 2.1. If we see a version 3, I would expect it to be a similar complete rethinking of OAuth from the ground up, where it would be probably a lot of terminology differences from OAuth 2. Certainly, libraries would not be expected to work from OAuth 2 with an OAuth 3 system, things like that. There is currently no OAuth 3 like roadmap. That doesn't exist. We don't know what's going to be eventually called OAuth 3 if that even exists. Right now, it's funny because OAuth 2 has been around for a very long time, but also it works. And one of the nice things about something that's been around for a long time is that there's a lot of experience with it and a lot of industry knowledge. So it's not, old things aren't necessarily bad, right? I know as developers, we're often like, oh, you got to use the latest JavaScript framework because the one from last year is bad because people decided that the old way of doing things is bad and this new way is better. And that's just not how the world of security works, really. There's a lot more incremental growth and small, building on past experience and making smaller improvements that can be done incrementally and without completely breaking changes. So I don't have a crystal ball to say, okay, this is what OAuth 3 is going to be or when, because there isn't necessarily that there isn't anything called OAuth 3 at the IETF right now. So
I see a comment here, and excellent points, Aaron from Vittorio Bertocci. Thanks. So basically, you're saying that OAuth 0.3 is still something that we know nothing about. Maybe it will be, may not. But are there any particular features that we should start thinking of that you guys are, discussing in your meetings? Like, hey, we believe that this can be improved. We have idea for that feature. We already know about Pixie. We already know about other improvements. But what is yet to know that is not yet that adopted? Because Pixie is kind of already adopted, because people are using it. We know that when you do your research, you find that legacy, not legacy, but implicit flow is kind of already called legacy. And also you said that it's going to be thrown away from the spec, this implicit flow. So what are the other things that are not yet like out there that is hidden behind the doors of your meetings?
yeah, well, hopefully it's not super hidden. Like, this stuff is supposed to be done in public, and it is, and it's all the documents are public. So hopefully you can find them. In fact, I'll send you another link here where you can show on the screen, so that if you do want to follow along with the sort of bleeding edge work of what is being done, this page, oauth.net/specs. This is where it lists all of the current documents that are not yet official standards, don't have RFC numbers yet, or maybe are even not adopted by the working group yet. So a couple of the ones on here that I would call out as useful things to keep in mind and things you may see in the future in products or libraries. One of the ones that actually just got its RFC number, which I'm really excited about, is called pushed authorization requests.
Pushed authorization request, right?
Yep, pushed authorization request, RFC 9126, finished in July. And the whole idea with that one is that, you know how normally when you start an OAuth flow, the client starts the flow by just redirecting the user's browser to the OAuth server. And in that redirect, there's a whole bunch of things in the URL that describe what the app is trying to do, like what scope it's requesting, the redirect URL of where to send the user back to, that kind of stuff. Because that is sent from the application to the browser to cause the browser to go to the OAuth server, the app is actually not talking to the OAuth server directly, right? The app is not making a request to the OAuth server. The app is telling the browser to make a request to the OAuth server, which means as a user, you could actually change what the app is requesting. So if the app is saying, hey, I'm trying to access...
Intercept this, right?
Yeah, exactly. So if the app is trying to get access to your contacts, you could say, because you click on that link and as the user, your browser includes that contact scope in the URL. As a user, you could take it out or change it to something else. And then the OAuth server thinks the app is requesting something else that the app didn't request, right? Because that's what shows up at the OAuth server. So this is... it sounds a little bit silly when I'm describing this particular attack, if you will. It is technically an attack. And it sounds a little bit silly because there's not a lot of damage you can do because you're really only affecting your own account and things like that. But as you start using OAuth for more and more things, and as you're doing things that are more complicated than just a simple scope that says contacts, that can start to become a problem. For example, imagine you were trying to authorize a payment request to say, hey, the client is trying to say, I would like to initiate a payment request for $20 from or to this account. Now, that is a very specific request the app is making. And if the user can change that, that could then cause problems. The user could be like, oh, well, I'm going to actually trick the OAuth server into saying that the app is requesting only $10 instead of 20. And now that's a problem for the app because it needed the $20.
Mm-hmm.
So ideally, we should avoid using the front channel for that first request. The front channel being that redirect.
That's also sorry to jump in, but can you also tell us, because this is very very interesting to distinguish the front channel and the back channel, right?
Mm-hmm.
Can you elaborate on that?
Yeah, totally. So this is a it's not necessarily spelled out in the spec, but it's like a concept that is used in all of the OAuth flows. The back channel is when a piece of software makes an HTTP request to a server. So it's an HTTP client to an HTTP server. And that gives you a lot of very useful security properties, like you can validate the certificate, you know that the connection's encrypted, you know that the message was delivered because and the response that comes back you can trust because it was all part of that same connection. So I like to think of the back channel as like hand delivering a message where you can walk up to somebody and give them something and you know that it worked. You know that they got it and you know it wasn't stolen. The front channel, on the other hand, is the idea of we're going to actually use the address bar, the user's address bar, to move data between two other pieces of software. So for the way that we use this in OAuth is there's two uses of the front channel. There's the OAuth client starts the flow in the front channel by redirecting the user's browser to the authorization server. And then the second front channel use is the authorization server redirecting back to the client. And in that redirect, it includes the authorization code. Now, the implicit flow redirects back with the access token in that redirect, and that's the real problem because it's sending the access token in the front channel. Yeah.
Yes.
The problem is that it's putting the access token in the front channel, and the front channel is not there's only so many layers of protection you can add onto it, and there's always this inherent issue with using the front channel. So the front channel is more like if you were trying to send me something, you would put the thing in the mail and then have it show up in the mail. And now, if you just imagine that scenario on both sides of that picture, if you put something in the mail, you don't know if it's going to make it to the destination, right? And even if it does make it to the destination, you don't know if someone opened up the mail in transit and then sealed it back up and made a copy of what was inside, right? You can't prove that anymore. And if you get something in the mail, you also can't even guarantee where it came from because the return address doesn't really mean anything. So there's no proof that it came from who you think it's from. So those are properties of the front channel when you're using the browser redirect that you can't avoid. So in the OAuth world, if the client is redirecting it to the OAuth server, what it's actually trying to do is send some sort of message to the OAuth server, but instead of sending the message directly, it tells the browser to send the message. Now you've got this problem of it didn't make that request directly, so it can't know if it made it or if it was tampered with. So, go ahead.
Yeah, I'm saying that's why I'm trying to now narrow down this into this pushed out request, because from what I try to understand, you're saying that now we should alleviate this even more, this problem of using front channel via this pushed authorization request, right? How would it work?
So like I said, OAuth has two uses of the front channel because the client needs to send the user to the OAuth server and the OAuth server has to send the user back to the client. So we can solve the return redirect by using Pixie. And that's so that we can make sure we're not ever sending access tokens in the front channel. We're only sending temporary things that can be protected. The problem is that we've still initiated the OAuth flow in the front channel in a way that can't be guaranteed that it wasn't tampered with. So push authorization request solves that by starting the OAuth flow in the back channel. So the OAuth client starts by making a post request to the OAuth server saying, here's what I'm trying to do. I'm looking for this scope. Here's my redirect URL. If it's got the more complicated things like I'm trying to get $20 from this user account sent to this address, that can all be part of the back channel request. And then what gets sent back to the client is just an opaque identifier, just like it would be like the authorization code where it doesn't mean anything, it's just a random string. That is then sent in the front channel. So that
Okay.
way, what goes in the front channel is something that doesn't actually contain any data and can't be modified because it doesn't actually mean anything by itself. So you start the flow in the back channel, and then you, of course, still have to use the front channel, but what's sent in the front channel is something that doesn't actually contain data. So there's no opportunity for the user or an attacker to modify it.
Okay. And when can we expect it so that we can
Well,
implement it?
it is an RFC now, so you can definitely implement it. As far as when it gets shipped in products like OAuth, open source OAuth servers, or actual services like Okta or Auth 0, I don't know. That's something that's up to each of those projects to decide when it makes sense for them to implement. So you have to check the specific roadmap of whatever product you're talking about. But the spec itself is stable now, is an RFC, and that means it's done.
You mean because the specs may have a different labels, or one the RFC may be informational, maybe standard, as far as I remember. So what kind of RFC is that?
This one is a full-on like standards track document.
Wow.
It is ready for people can implement against this RFC and expect it to not change.
So if Google decides, like, we now have the spec that we can implement in our some STS and so on, right?
Yeah, exactly. So I would expect it at this point to start seeing it show up in OAuth servers and in open source projects if you need that security property.
I get it. So is Okta going to provide it soon?
I honestly I don't know. I don't know much about the roadmap of Okta. Unfortunately, I'm not really part of that team, so
Cool.
can't say anything there.
Mhm. Perfect. That's great. So, is there anything else that, I mean, because this is quite of like an important thing to know, that we can avoid this risk of initiating the flow with front-end channel, like
Mhm.
putting the scopes, all the nitty-gritty inside of the URL, right? So that's, I believe, if you guys have any questions, I got it, I understood it. If somebody would like to follow up on that, I believe we can ask Aaron some more detailed questions. Is there anything else that is coming that we should and it's nice that we can actually learn from you that there's those new things.
Yeah, a couple other. Let's see. There's there's another one that's at the top of this list on this page, that specs page, rich authorization requests,
Reach authorization request, right?
which is solving a completely different problem, but it's closely related to push authorization requests because of what it enables. So this one is meant for describing OAuth requests that can't be described using scope. So scope is useful if the app is trying to do something like, say, I would like to access your contacts. Cool. Contacts is a concept made up by the resource server, and it can be expressed in a scope as a string. You could then go further and say, I would like to update your contacts, or I would like to only have read access. Those can all be described by scopes. Fine. What can't be described by scopes is the more transactional or fine-grained things like, I would like to access 2 of your 4 bank accounts, these 2 bank accounts. Or I would like to be able to make a payment up to $100, or make a payment of exactly $2.99. Those things, you can't really do them as scopes because scopes have to be pre-registered, and you can't really make a scope for every possible dollar amount.
Yeah,
And
they are discrete. They are discrete tokens, right?
yeah, they're too granular to be expressed by scopes. So what rich authorization requests does is it provides this framework for expressing those kinds of things. So there is now like a JSON structure basically that says, if you're trying to authorize a payment of a certain amount, you could actually put in an account number or a dollar amount into this JSON structure and make that part of your OAuth request like you would be using scope. And that is where it then becomes very apparent that you would not want to put that in the front channel in the URL because it's too easy to have things modify it. And that's then that's why it's very closely linked to push authorization requests, because something that in the back channel makes a lot of sense. So the reason I'm excited about this is because it opens up a ton of possibilities for using OAuth for things we haven't been able to before, like these payment initiations or things like that, or access to certain records in a database, rather than the concept of like see all of your files. You could say, I am trying to access only this one folder, or trying to access only the specific resources within this resource server. So a lot of really cool use cases that opens up, that makes possible. And one of the reasons if you read the spec, you'll find there's examples of actually money finance stuff in the spec, because it is being driven from that world of the use case. So that is a good sign to me, because the finance world has been slow to adopt OAuth, and I think it's partly because there have been limits in terms of what's really possible with it. So this is opening that all up, and I'm very excited to get a lot more OAuth support in banking APIs.
Just a quick, because you said you have a meeting just after. So how much time do we have left?
We have till the top of the hour, and then I got to go work on OAuth 2.1.
Perfect. So we have 15 minutes left. So I will try to steer the conversation so that we can have a decent summary. So we have learned about pushed out request, reach out request. What is more that we can easily grasp in this conversation? That that's fine, that's great. That I believe that if this becomes a reality, I know where I can use it. What other things like that?
I would say the other sort of largest category to talk about is the concept of client authentication. So you mentioned earlier that some clients can use client secrets and others can't. So if your app is running on a web server and you have a server-side language, you can provide it a client secret from the OAuth server, and nobody using the app will be able to know the secret. That's the whole point of it.
Mm-hmm.
If you are writing a single page app or a mobile app, you cannot do that. There's no way to put a client secret into that app and have it remain secret. And that has been sort of the way that OAuth has been modeled for a long time, in the way that it works. We lose a lot of we lose some aspects of some security properties when we don't have a client secret. Primarily, we no longer can. There's a possibility of app impersonation, where someone can ship an app that sort of acts exactly like some other native app that the OAuth server can't tell that it's not that app. And that one's actually almost impossible to solve, so that's less interesting to me. But the more interesting one is that a particular mobile app that somebody downloads, it would be nice if we could identify that particular instance throughout the entire life cycle of the user using that app. So when I download an app from the App Store, I get a copy of that code on my phone. And if you download that same app, you get a copy of that code on your phone, and they are not connected, right? So we obviously can't ship a client secret in the App Store, because then we would have the same client secret, and then it doesn't do anything anymore. So what would be nice is if that app could have that instance could have its own credential. So think about it like, when I download the app from the App Store, imagine that it made up a secret the first time it launched. And now that secret identifies my instance of the app.
Right? Your copy of the code, right?
My copy of the code is identified now by this credential. Now, the OAuth server can't use that as a credential that says like, oh yeah, this really is the one from the App Store. But what it can use that for is the first time I log in, it can associate with that credential on the phone. And if I come back 2 months later and log in again, it can know that it's the same app. And more importantly, if somehow the access token or refresh token that were issued to my instance were leaked and tried to be used by somebody else's app, we could tell that it was being used by a different instance of the app and not my instance. So the ability to identify particular instances of apps is very useful and does give us even more security than not having a secret at all. We just can't issue these secrets ahead of time. They have to be created on the fly by the instance themselves. So that's the sort of description of the general description of the problem. And then how we actually do that is described in a couple of these other specs. And
So
that's where it
basically,
starts to get a
you're
little bit
saying
messier.
that instead of giving the secret upfront, whenever I make my copy of the code, my instance is going to be somehow generated for this particular instance on the fly, not upfront. Is there any
Yeah.
technical way already to achieve that?
So yeah, we can talk about the actual the specs that are related to this concept now. But that's sort of the underlying idea. And then the way that you would actually build this is, first of all, let's stop using shared secrets entirely first, because it turns out shared secrets are not a very good security thing to do. That's why we are trying to move away from passwords. So, Brandon's asking hashed IMEI or Google App ID. So the again kind of like a shared secret, because it's known by both the provider, like the cell provider or the app store, as well as the phone. And that means if it's a shared secret, it can also be faked. It can be copied. So ideally, we're trying to find something that can be even more secure than a shared secret, which is where we start getting into cryptography. So public private key crypto is very, very useful for this, because what it means is that the phone can generate a certificate which it can use to sign things. And if since we now do actually have the ability for phones to create certificates that can't even be extracted from the phones, like that's how Touch ID works and Face ID. Those are private keys that can't be extracted from the phones. Those are only able to sign things. Then we actually get much higher level of assurance of security along the way. So there's a couple of specs that you can use for this, and they are, I would say, still quite experimental. And this is something I would say, if you're implementing this right now, expect to change it by the time these specs make their way to an RFC number. But that's the DPOP spec. So that's DPOP. And then
Can you send me a private message so I can, or type in a chat so I can share it?
Yeah, I'll copy the full name of it here. So there's demonstration of proof of possession at the application layer, or DPOP. There's also a brand new experimental one using HTTP message signatures, and there's also the older one that is challenging to implement in certain deployments, which is mutual TLS. And I think those are the three sort of main ideas around this, or specs around this idea of trying to actually tie an OAuth flow to a particular instance of an app, and that way you can issue the access token and the refresh token, tie it to a specific instance of the app, so that there's no way to have those be useful by any other instances of the app if they happen to be stolen. So a couple of different approaches, and even though mutual TLS is already an RFC, I think there's I've heard a lot of people complain about deployment challenges, essentially, because it means that you have to do your infrastructure in a certain way in order to get the client certificate. Anyway, that's too much detail for this conversation. But there are these three sort of parallel approaches being worked on right now, and they all accomplish the same goal of assigning of being able to have a private key live in the instance of the app that is even potentially created by that instance on its own, so that it can't be extracted ever, and use that to sign requests that are to the OAuth server, or using an access token. And that way you just can't steal access tokens anymore, because they don't do anything.
Yeah, that was quite an interesting idea, that you can use your Touch ID, for example, or Face ID as a only known to you private component of public and private cryptography, right? Because this we have the possibility to have this unique thing to use for private and public cryptography. But how about websites? Because this is probably something that is feasible or physically possible with the Touch ID, Face ID on the mobile. But how about websites?
Well, the good news is websites are getting those APIs too. So with Touch ID on all the Mac laptops, it works the same way, where there is a browser API that can be used to interact with that, and it is also it's the same thing where it's a private key that lives in the trusted compute module and it can't be extracted, and there is a browser API to interact with it. So I think Windows has a similar thing. I don't remember the name of it, but it's the way that Windows Hello is implemented. But that's the great news is like this is something that wasn't possible 10 years ago because these ideas just didn't exist. And now not only do the concepts exist, but they're actually getting built into browsers, both mobile and desktop.
I'm looking at the timer. We have 4 minutes, and I have the last question that I wanted to ask you. So, can you just give us a short, like bird's eye view? Because everything is fine, but I know that as a person who was actually very deep into this different things, that for some people or some organizations, implementing this in their own on premises is too much of a hassle, and they want to use so-called identity as a service, right? We know that Okta is kind of in this space, and Auth0. So, how do you see the future of the whole identity as a service? Having in mind all the different challenges and changes and ideas coming to the future.
Yeah, and I don't want this to come off as like a sales pitch, but I do honestly think that this stuff is very complicated to get right. And as developers using OAuth and interacting with OAuth services, there's a lot that you just don't have to worry about because it is done by client libraries. It is there's even less of a just stuff you have to worry about if you're building an OAuth client. If you're building an OAuth server or dealing with actually managing user accounts, then there is a huge list of stuff to deal with, right? You have to deal with storing passwords in the first place, and then password recovery. You have to deal with implementing MFA, multi-factor authentication, and recovery methods for those. And there's just this huge long list. And within OAuth, then there's a long list of things you have to do in order to implement it securely. And that list is much longer on the provider side compared to the OAuth client side. And I think that is why identity as a service companies are a good idea, because that stuff is hard to get right. And it is also not terribly interesting to your particular problem of what you're actually building. Because most of us are trying to build a product that does something. And logging into that is just it's the thing we have to do in order to be able to have people use the product. It's not the actual goal of the product. There's no real reason to have login as its own feature. That is not a thing, right? That does not exist. I'm not going to be like, I'm going to build the best login website today, and then people are going to log into it. That doesn't exist. People are like, I'm trying to build an accounting system. I'm trying to build a budgeting app. I'm trying to store photos in a website. That's what you're trying to do. And the getting logged into that is just sort of a thing that has to get done. And I think that's why it's very useful to have that handled by something else so that you don't really have to worry about it. And also that means that keeping track of all these changes is the job of that service. Really good example, like Vittorio mentioned, WebAuthn, which is the API that browsers can use to interact with Touch ID and Face ID and those platform authenticators. That is a new thing that came up in the last several years. And if you want to go and add support to that to your website and you've built your login system from scratch, you would have to go read that API and figure out how it works and write code to deal with it and integrate it. If you're using a platform like Okta or Auth0, they go and implement that because that is their job, and it's their job to track these changes and make sure that they're doing it the most secure way and keeping up to date on what are all the different options. And suddenly you can just sort of turn it on by clicking a button, right? You don't have to worry about writing a ton of code because it's all handled over there. So I think that's really the main benefit, and that's where we expect the likes of Okta and Auth0 to be tracking the best practices and tracking the changes in the specs and implementing those features so that you can take advantage of them without writing any code to do it. So that's, I think, where I see
Yeah,
that
basically, I
happening.
totally agree with you. This stuff is really complex in terms of the way the things you need to remember to care about when you implement it on your own. I just did it like a shameless plug that yeah, that's why I created the Web Security Academy, and I'm trying to help developers actually first understand what is the problem space and what is the necessary theory, and then we build actually this stuff in the course. But one of the modules that I also have, so hey, we have spent several weeks building that, but hey, there is this service which is called OAuth 0, and now everything that we have built, we can just move into the platform which provides it as a service. Of course, you have to pay for it, but then it's going to be done by you. So you now you are like fully aware what is the problem, how complex is that, and you can build it on your own because now you can, right? But you can pay and get it delivered by the external company. So I was just smiling that you were mentioning that how complex is that, and it is not that sexy because you're building a feature, and login is just a necessary thing that has to be there. And I was like showing Web Security Academy because basically this is whole education stuff that I'm involved in because it is really complex. So you either you build it on your own, right? Either you pay for the service, which is in this case Okta OAuth 0, which probably in some cases is a better choice for different projects and so on. So I know we are over time, and first of all, thank you very much, Aaron. And if you guys have any questions right now, maybe Aaron would stay a minute more to answer them. If not, then again, thank you for your time. We have learned a couple of interesting ideas that are coming to off, and we know that these things are changing. And maybe last questions: when do you know that? I will show you this comment. When do you know that we can expect, for example, so what is the current state of the formal status of point 2.1? Is it like already released, or is it draft? What is the current state of that?
Yeah, it is currently a draft. It is officially adopted by the working group, which means it is something that is agreed on by the group as this is something that we would like to exist and actively spend time on as a group. It is in draft 3 right now, which was published just a couple of weeks ago. And we are expecting to have a meeting, an interim meeting, which is where the group meets and discusses the stuff and sort of figures out the remaining issues of what we need to talk about. That is scheduled for a couple of weeks from now. So this stuff is moving forward. I do have to run to this meeting to actually continue working
Yes.
through these issues. But yeah, it is still a draft, so it is still in progress, which means if anybody has input on it, that is also very welcome at the moment.
So Aaron, I don't want to stop you. You can see that there are amazing session. Thank you guys. We need to let Aaron jump into the actually of discussion to move things forward. So thank you, Aaron, and thank you guys for joining. The video is stay on YouTube, so you can watch the replay. And one more time, I hope to see you soon, Aaron, and let's join the next call. Thank you.
Yeah, thanks for having me.